And so, yeah, we spent maybe 2 years here, and the chocolate factory was just downstairs, so it always smelled really nice. And yeah, I guess the team was, 10, 20 less. And yeah, we had a few very fun episodes here. One of them was alluded to by Jensen at GTC that happened just yesterday or 2 days ago. So Jensen was describing how he brought the first DGX and how he delivered it to OpenAI. So that happened right there. So that's where we all signed it. It's in the room over there.
So Andrej needs no introduction, but I wanted to give a little bit of backstory on some of his journey to date. As Sonia had introduced, he was trained by Jeff Hinton and then Fei. His first claim to fame was his deep learning course at Stanford. He co-founded OpenAI back in 2015, and in 2017 he was poached by Elon. I remember this very, very clearly. For folks who don't remember the context, then Elon had just transitioned through 6 different autopilot leaders, each of whom lasted 6 months each. And I remember when Andrej took this job, I thought, congratulations and good luck. Not too long after that, he went back to OpenAI and has been there for the last year. Now, unlike all the rest of us today, he is basking in the ultimate glory of freedom in all time and responsibility. And so we're really excited to see what you have to share today. A few things that I appreciate the most from Andrej are that he is an incredible, fascinating futurist thinker. He is a relentless optimist, and he's a very practical builder. And so I think he'll share some of his insights around that today. To kick things off, AGI, even 7 years ago, seemed like an incredibly impossible task to achieve, even in the span of our lifetimes. Now it seems within sight. What is your view of the future over the next N years?
Yeah, so I think you're right. I think a few years ago, I sort of felt like AGI was, it wasn't clear how it was going to happen. It was very sort of academic, and you would think about different approaches. And now I think it's very clear, and there's a lot of space, and everyone is trying to fill it. And so there's a lot of optimization. And I think, roughly speaking, the way things are happening is everyone is trying to build what I refer to as kind of like this LLM OS. And basically, I like to think of it as an operating system. You have to get a bunch of basically peripherals that you plug into this new CPU or something like that. The peripherals are, of course, like text, images, audio, and all the modalities. And then you have a CPU, which is the LLM transformer itself. And then it's also connected to all the software 1.0 infrastructure that we've already built up for ourselves. And so I think everyone is kind of trying to build something like that and then make it available as something that's customizable to all the different nooks and crannies of the economy. And so I think that's kind of roughly what everyone's trying to build out and what we sort of also heard about earlier today. So I think that's roughly where it's headed is we can bring up and down these relatively self-contained agents that we can give high-level tasks to and specialize in various ways. So yeah, I think it's going to be very interesting and exciting. And it's not just one agent, it's many agents. And what does that look like?
And if that view of the future is true, how should we all be living our lives differently?
I don't know. I guess we have to try to build it, influence it, make sure it's good, and yeah, just try to make sure it turns out well.
So now that you're a free, independent agent, I want to address the elephant in the room, which is that OpenAI is dominating the ecosystem. And most of our audience here today are founders who are trying to carve out a little niche, praying that OpenAI doesn't take them out overnight. Where do you think opportunities exist for other players to build new independent companies versus what areas do you think OpenAI will continue to dominate even as its ambition grows?
Yeah, so my high-level impression is basically OpenAI is trying to build out this LLM OS. And I think, as we heard earlier today, it's trying to develop this platform on top of which you can position different companies in different verticals. Now, I think the OS analogy is also really interesting because when you look at something like Windows or something like that, these are also operating systems. They come with a few default apps, like a browser comes with Windows, right? You can use the Edge browser. And so I think in the same way, OpenAI or any of the other companies might come up with a few default apps, quote unquote, but that doesn't mean that you can have different browsers that are running on it, just like you can have different chat agents sort of running on that infrastructure. And so there will be a few default apps, but there will also be potentially a vibrant ecosystem of all kinds of apps that are fine-tuned to all the different nooks and crannies of the economy. And I really like the analogy of the early iPhone apps and what they looked like, and they were all kind of like jokes. And it took time for that to develop. And I think absolutely I'd agree that we're going through the same thing right now. People are trying to figure out, what is this thing good at? What is it not good at? How do I work it? How do I program with it? How do I debug it? How do I just, actually get it to perform real tasks? And what kind of oversight, because it's quite autonomous, but not fully autonomous. So what does the oversight look like? What does the evaluation look like? So there's many things to think through and just to understand sort of like the psychology of it. And I think that's what's going to take some time to figure out exactly how to work with this infrastructure. So I think we'll see that over the next few years.
So the race is on right now with LLMs, OpenAI, Anthropic, Mistral, Llama, Gemini, the whole ecosystem of open source models, now a whole long tail of small models. How do you foresee the future of the ecosystem playing out?
Yeah, so again, I think the open source operating systems analogy is interesting because we have, we have basically an oligopoly of a few proprietary systems, like say Windows, Mac OS, etc. And then we also have Linux. And Linux has an infinity of distributions. And so I think maybe it's going to look something like that. I also think we have to be careful with the naming because a lot of the ones that you listed, like Llama, Mistral, and so on, I wouldn't actually say they're open source, right? And so it's kind of like tossing over a binary for like an operating system. Like you can kind of work with it, and it's like useful, but it's not fully useful, right? And there are a number of what I would say is like fully open source LLMs. So there's Pythia models, LLM 360, Olmo, etc. So and they're fully releasing the entire infrastructure that's required to compile the operating system, right? To train the model from the data, to gather the data, etc. And so when you're just given a binary, it's much better, of course, because you can fine-tune the model, which is useful. But also, I think it's subtle, but you can't fully fine-tune the model because the more you fine-tune the model, the more it's going to start regressing on everything else. And so what you actually really want to do, for example, if you want to add capability, is and not regress the other capabilities, you may want to train on some kind of like a mixture of the previous dataset distribution and the new dataset distribution, because you don't want to regress the old distribution, you just want to add knowledge. And if you're just given the weights, you can't do that, actually. You need the training loop, you need the dataset, etc. So you are actually constrained in how you can work with these models. And again, I think it's definitely helpful, but I think we need slightly better language for it almost. So there's open weights models, open source models, and then proprietary models, I guess. And that might be the ecosystem. And yeah, probably it's going to look very similar to the ones that we have today.
And hopefully you'll continue to help build some of that out. So I'd love to address the other elephant in the room, which is scale. Simplistically, it seems like scale is all that matters. Scale of data, scale of compute, and therefore the large research labs, large tech giants have an immense advantage today. What is your view of that? And is that all that matters? And if not, what else does?
So I would say scale is definitely number one. I do think there are details there to get right, and I think a lot also goes into the data set preparation and so on, making it very good and clean, etc. That matters a lot. These are all sort of like compute efficiency gains that you can get. So there's the data, the algorithms, and then of course the training of the model and making it really large. So I think scale will be the primary determining factor, is like the first principal component of things for sure. But there are many of the other things that you need to get right. So it's almost like the scale sets some kind of a speed limit almost, but you do need some of the other things. But it's like if you don't have the scale, then you fundamentally just can't train some of these massive models if you are going to be training models. If you're just going to be doing fine tuning and so on, then I think maybe less scale is necessary, but we haven't really seen that just yet to fully play out.
And can you share more about some of the ingredients that you think also matter, maybe lower in priority behind scale?
Yeah, so the first thing I think is you can't just train these models. If you're just given the money and the scale, it's actually still really hard to build these models. And part of it is that the infrastructure is still so new and it's still being developed and not quite there. But training these models at scale is extremely difficult and is a very complicated distributed optimization problem. And there's actually the talent for this is fairly scarce right now. And it just basically turns into this insane thing running on tens of thousands of GPUs. All of them are failing at random at different points in time. And so instrumenting that and getting that to work is actually an extremely difficult challenge. GPUs were not intended for 10,000 GPU workloads until very recently. And so I think a lot of the infrastructure is sort of creaking under that pressure. And we need to work through that. But right now, if you're just giving someone a ton of money or a ton of scale or GPUs, it's not obvious to me that they can just produce one of these models, which is why it's not just about scale. You actually need a ton of expertise, both on the infrastructure side, the algorithm side, and then the data side, and being careful with that. So I think those are the major components.
The ecosystem is moving so quickly. Even some of the challenges we thought existed a year ago are being solved more and more today. Hallucinations, context windows, multimodal capabilities, inference getting better, faster, cheaper. What are the LLM research challenges today that keep you up at night? What do you think are immediate enough problems, but also solvable problems that we can continue to go after?
So I would say on the algorithm side, one thing I'm thinking about quite a bit is this like distinct split between diffusion models and autoregressive models. They're both ways of representing probability distributions, and it just turns out that different modalities are apparently a good fit for one of the two. I think that there's probably some space to unify them or to like connect them in some way, and also get some best of both worlds, or sort of figure out how we can get a hybrid architecture and so on. So it's just odd to me that we have sort of like two separate points in the space of models, and they're both extremely good, and it just feels wrong to me that there's nothing in between. So I think we'll see that sort of carved out, and I think there are interesting problems there. And then the other thing that maybe I would point to is there's still like a massive gap in just the energetic efficiency of running all this stuff. So my brain is 20 watts roughly. Jensen was just talking at GTC about the massive supercomputers that they're going to be building now. The numbers are in megawatts, right? And so maybe you don't need all that to run like a brain. I don't know how much you need exactly, but I think it's safe to say we're probably off by a factor of 1,000 to like 1,000,000, somewhere there, in terms of like the efficiency of running these models. And I think part of it is just because the computers we've designed, of course, are just like not a good fit for this workload. And I think NVIDIA GPUs are like a good step in that direction. In terms of like you need extremely high parallelism. We don't actually care about sequential computation that is sort of like data dependent in some way. We just have these, we just need to like blast the same algorithm across many different sort of array elements, or something. You can think about it that way. So I would say number one is just adapting the compute architecture to the new data workflows. Number two is like pushing on a few things that we're currently seeing improvements on. So number one maybe is precision. We're seeing precision come down from what originally was like 64-bit for double. We're now down to, I don't know what it is, 4, 5, 6, or even 1.58, depending on which papers you read. And so I think precision is one big lever of getting a handle on this. And then the second one, of course, is sparsity. So that's also like another big delta, I would say. Like your brain is not always fully activated. And so sparsity, I think, is another big lever. But then the last lever, I also feel like just the von Neumann architecture of like computers and how they build, where you're shuttling data in and out and doing a ton of data movement between memory and the cores that are doing all the compute. This is all broken as well, kind of, and it's not how your brain works, and that's why it's so efficient. And so I think it should be a very exciting time in computer architecture. I'm not a computer architect, but I think there's, it seems like we're off by a factor of 1,000 to 1,000,000, something like that. And there should be really exciting sort of innovations there that that bring that down.
I think there are at least a few builders in the audience working on this problem. Okay, switching gears a little bit. You've worked alongside many of the greats of our generation. Sam, Greg from OpenAI, and the rest of the OpenAI team, Elon Musk. Who here knows the joke about the rowing team, the American team versus the Japanese team? Okay, great. So this will be a good one. Elon shared this at our last base camp, and I think it reflects a lot of his philosophy around how he builds cultures and teams. So you have two teams. The Japanese team has 4 rowers and 1 steerer, and the American team has 4 steerers and 1 rower. And can anyone guess, when the American team loses, what do? Shout it out. Exactly. They fire the rower. And Elon shared this example, I think, as a reflection of how he thinks about hiring the right people, building the right teams at the right ratio. From working so closely with folks like these incredible leaders, what have you learned?
Yeah, so I would say definitely Elon runs his companies in an extremely unique style. I don't actually think that people appreciate how unique it is. You sort of like even read about it and so much, you don't understand it, I think. It's like even hard to describe. I don't even know where to start, but it's like a very unique, different thing. Like I like to say that he runs the biggest startups, and I think it's just I don't even know basically like how to describe it. It almost feels like it's a longer set of thing that I have to think through. But well, number one is like, so he likes very small, strong, highly technical teams. So that's number one. So I would say at companies by default, they sort of like the teams grow and they get large. Elon was always like a force against growth. I would have to work and expend effort to hire people. I would have to like basically plead to hire people. And then the other thing is that big companies, usually you want, it's really hard to get rid of low performers. And I think Elon is very friendly to, by default, getting rid of low performers. So I actually had to fight for people to keep them on the team because he would by default want to remove people. And so that's one thing. So keep a small, strong, highly technical team. No middle management that is kind of like non-technical for sure. So that's number one. Number two is kind of like the vibes of how everything runs and how it feels when he sort of like walks into the office. He wants it to be a vibrant place. People are walking around, they're pacing around, they're working on exciting stuff, they're charting something, they're coding. You know, he doesn't like stagnation. He doesn't like for it to look that way. He doesn't like large meetings. He always encourages people to like leave meetings if they're not being useful. So actually, you do see this, or you know, it's a large meeting, and if you're not contributing and you're not learning, just walk out. And this is like fully encouraged. And I think this is something that you don't normally see. So I think like vibes is like a second big lever that I think he really instills culturally. Maybe part of that also is like, I think a lot of bigger companies, they like pamper employees. I think like there's much less of that. It's like the culture of it is you're there to do your best technical work, and there's the intensity and so on. And I think maybe the last one that is very unique and very interesting and very strange is just how connected he is to the team. So usually a CEO of a company is like a remote person 5 layers up who talks to their VPs, who talk to their reports and directors, and eventually you talk to your manager. That's not how your company is, right? Like he will come to the office, he will talk to the engineers. Many of the meetings that we had were like, 50 people in the room with Elon, and he talks directly to the engineers. He doesn't want to talk just to the VPs and the directors. Normally people would spend like 99% of the time maybe talking to the VPs. He spends maybe 50% of the time, and he just wants to talk to the engineers. So if the team is small and strong, then engineers and the code are the source of truth. And so they have the source of truth, not some manager, and he wants to talk to them to understand the actual state of things and what should be done to improve it. So I would say like the degree to which he's connected with the team and not something remote is also unique. And also just like his large hammer and his willingness to exercise it within the organization. So maybe if he talks to the engineers and they bring up that, what's blocking you? Okay, I don't have enough GPUs to run my thing. And he's like, oh, okay. And if he hears that twice, he's gonna be like, okay, this is a problem. So like, what is our timeline? And when you don't have satisfying answers, he's like, okay, I want to talk to the person in charge of the GPU cluster. And like someone dials the phone and he's just like, okay, double the cluster right now. Like let's have a meeting tomorrow. From now on, send me daily updates until the cluster is twice the size. And then they kind of like push back and they're like, okay, well, we have this procurement set up, we have this timeline, and NVIDIA says that we don't have enough GPUs and it will take 6 months or something. And then you get a rise of an eyebrow. And then he's like, okay, I want to talk to Jensen. And then he just kind of like removes bottlenecks. So I think the extent to which he's like extremely involved and removes bottlenecks and applies his hammer, I think is also like not appreciated. So I think there's like a lot of these kinds of aspects that are very unique, I would say, and very interesting. And honestly, like going to a normal company outside of that is you like definitely miss aspects of that. And so I think, yeah, that's maybe that's a long rant, but that's just kind of like, I don't think I hit on all the points, but it is a very unique thing, and it's very interesting. And yeah, I guess that's my rant.
Hopefully tactics that most people here can employ. Taking a step back, you've helped build some of the most generational companies. You've also been such a key enabler for many people, many of whom are in the audience today, of getting into the field of AI. Knowing you, what you care most about is democratizing access to AI, education, tools, helping create more equality in the whole ecosystem at large. There are many more winners. As you think about the next chapter in your life, what gives you the most meaning?
Yeah, I think you've described it in the right way. Like where my brain goes by default is, I've worked for a few companies, but I think like ultimately I care not about any one specific company. I care a lot more about the ecosystem. I want the ecosystem to be healthy. I want it to be thriving. I want it to be like a coral reef of a lot of cool, exciting startups and all the nooks and crannies of the economy. And I want the whole thing to be like this boiling soup of cool stuff. And
genuinely, Andrej dreams about coral reefs.
I want it to be like a cool place. And I think, that's why I love startups and I love companies. And I want there to be a vibrant ecosystem of them. And by default, I would say a little bit more hesitant about kind of like, like 5 megacorps kind of like taking over, especially with AGI being such a magnifier of power. I'm kind of worried about what that could look like and so on. So I have to think that through more, but yeah.